Alright nerds, so we're about to jump in to radioactivity, and let's just get our pen ready and away we go. Alright, so what's the point? What are we doing? Basically, by the end of this, you want to be able to describe what radioactivity or radiation is. You want to understand the three different types of radiation, they're physical beings, and you want to be able to, the implications for what they can mean. Okay, let's get into it. So first off, we've got here a radioactive particle, a radioactive atom, and we actually see a particle leaving with energy, and that's important because remember, radioactivity or radiation is energy. So, but a radioactive atom or radioactivity is the spontaneous decay of an unstable atom. It's essentially the nucleus of an atom falling apart because it's too heavy. It just can't quite stay together, and we call this radioactive decay. So that's pretty interesting. Alright, now there are three types that we're really concerned with, and they all come from an unstable nucleus of an atom. So you have the alpha particle, which is 2 protons, 2 neutrons. Now that causes, so they leave, and that changes the atom because it just got smaller. It just lost 2 protons. We have the beta particle. Now what a beta particle does is it a neutron changes into a proton, okay, and when a neutron which has a net charge of 0 changes into something that has a charge of +1 and -1. So if we add those together, we still get 0. Charge is still conserved, and it changes a neutron into a proton and an electron, and the electron flies off, and that is a beta particle. So a beta particle is small, high energy, higher energy than this. So the order of energy goes 3 to 1. So it has high energy and it flies off the atom, and that's electron, and it's a beta particle. As a consequence of both of these, we end up with what we call gamma radiation. Now gamma radiation is just pure energy, and it's the surplus energy that flies away. Now, it's very high frequency and a very short wavelength. The atom is not changed, and that's because the atom is already changed, and it's actually, so it's a bit tough to see there, it's this little sort of wave-looking bit of energy there. Alright, so those are the three types of radioactivity. Whenever you get alpha or beta, you have gamma with it. Alright, so let's look at the penetrating power, so how far they go. Alpha particles, they're big, like they're really chunky, they're 2 protons, 2 neutrons. They can only go so far, like if they hit paper they stop, like that's enough to stop alpha radiation. Beta particles, they're smaller, so they're able to go through more things, and they have higher energy. But a sheet of aluminium about 2 or 3 centimeters thick is enough. Generally with a gamma emitter though, we saw it in lead or concrete, because it will pass through most things. It's, again, very short wavelength, which means it has in fact it's the shortest wavelength of all on the electromagnetic spectrum, which means it has the highest of energy, so it just pushes straight through. And no mass, so it's hard to stop. Alright, that's radiation. Enjoy.